Okay, so part A of question 2, 2015, this is an isomerism and stereochemistry question. First part is asking you to assign the configurations of the stereogenic centres. So I've labelled here centre 1, 2 and 3. You should be able to figure those out. So for first one here, we're going in order of priority of the groups that are attached. So this group here has first priority. The hydrogen is going backwards. So you're going to have 1, 2, the chlorine, because this is the next largest attached group, and then 3 over this side. So you're going to have your arrow coming around like this, which represents an S configuration. The second centre, this methyl group here, will be priority 1. You'll have your hydrogen coming back, which is priority 4. Coming up this side of the ring, chlorine is going to have higher priority. So you're going to have 3 here. So you're going to have the arrow coming around like this. Follow the arrow, it's going the opposite way, it's an R configuration. The final centre is the carbon attached to the chlorine. The chlorine is going to have highest priority. Next highest priority is going to be the carbon with the terpbutyl group attached. And then finally you have your methyl group coming around here as your third priority. So going off of that, your arrow would follow this path, which would represent an R configuration. However, because the chlorine is pointing backwards, and you have to have your higher priority groups pointing forwards, that will flip and will actually be an S configuration. The second part of the question is asking you to draw the 2 chair conformers and figure out which one is more energetically favoured. So, using the molecule here, I've labelled each carbon 1 through 6, drawn my chairs in both forms, and numbered them represent each carbon. So you can see with this arrangement here, arrangement A, you've got your terpbutyl group in the equatorial position, the chlorine in the equatorial position, and your methyl group in the axial position. For the second configuration, the terpbutyl and the chlorine are now axial, and the methyl group is now equatorial. What that means is that configuration A is going to be the more energetically favoured configuration. Firstly, because it has most equatorial groups out of both configurations. But secondly, the large terpbutyl group will act as a steric lock. It will not want to favour an axial position because it will want to reduce 1,3 diaxial strain. Part C, you've got to look at the alkene provided and figure out whether it is an E or Z configuration. Based off the functional groups you've got attached here, you can see that these hydrogens are on opposite sides, therefore it's an E alkene. That information is straight from the notes. Final part, part D, is asking you to draw the mechanism when you use osmium tetroxide and react it with the alkene you've been given. This will give you a dihydroxylation product, which is a concerted reaction. You're going to have the osmium tetroxide attacked from the top, like so. So following this round, this might be a bit more detail than you need. You have the osmium tetroxide here. The electron-rich alkene carbon is going to attack the oxygen. So we'll push electron density into the osmium, and then push it back down to attack the other alkene carbon. We will then have this 5-membered ring, 2 carbons, 2 oxygens, and the osmium. When you treat it with sodium hydroxide, the following is going to happen. The osmium is going to attack hydroxide, so you'll have 1 alcohol group here. The same again is going to happen. You end up with your final product. This happens in one stage, but I've broken it up for clarification. Cheers.